to really appreciate BFD, bidirectional. I was gonna check that out. Bidirectional forwarding detection in a Cisco network. Let's first of all take a look at a topology and take a look at if there's a change, how long it might take for the network to heal itself or find another path. And we'll also take a look at some reasons why that happens. And as we progress, we'll take a look at implementing bidirectional forwarding detection to solve that problem. Let's look at the topology. So in this topology, the critical ports that we want to be aware of are these guys right here. I've got gig 0/0 here and 0/2 here, and up off the switch is 0/0. And if we're running a dynamic routing protocol like OSPF, we would have adjacencies, and I'll put those in blue here. We'd have adjacencies here, and also between R2 and R4, and also R4 and R5, and R3 and R5, and R2 and R3. Great, no problem. So this is all Ethernet, it's all gigabit speed. And if the current path, let's imagine the path from R1 to get to R4, which if all the paths are equal, that would be the path it would take. Let's imagine that's the path it would take to reach the loopback of 4, 4, 4, 4. Now, if there was a problem with this link right there on R4, or if there was a problem with the switch, let's say the switch on that port had a problem, R2 is not going to directly sense that there's a link failure because it's got link coming from its port on the switch, and it might take 30 to 40 seconds for the network to figure out, hey, you know, this is not the best path, says R2, to get to 444. It needs to go ahead and use this path, but that could take like up to 40 seconds, and that is a long time. So instead of waiting that full time, what we could do is we could implement BFD, the bidirectional forwarding detection. And what it's going to do, it's going to send little messages back and forth, little love messages over the, in this case, the physical path would be over the switch. The logical path would be between them. Little messages saying, how are you? Good. Back and forth. And we can control that. We can specify how often that happens. Then it can be sub-second. Like we could send 4 or 5 a second back and forth. And then we could train OSPF to be linked to BFD. And so that if the BFD session fails, or if the BFD pings going back and forth, they're not really pings, they're BFD messages back and forth. If it fails, it can inform OSPF, and OSPF can say, hey, whoa, I don't need to wait any longer. BFD's not working, so I'm going to go ahead and assume that's done, and then they can go ahead and converge with the rest of the network in the correct path. So that's how bidirectional forwarding detection can work. Now, it can be used for a lot of things. We can use it for static routes, which is wonderful. So if you have a static route, and the next hop no longer becomes available, even though our link is up, but the next hop is not available. With BFD, it can say, hey, it's no longer up, and we can drop that out of the routing table immediately and not just leave that static route in the routing table. We can also use it with HSRP, Hot Standby Routing Protocol. There's an R there. We can also use it with BGP. Fantastic stuff. We can also use it with EIGRP, although EIGRP is pretty darn fast as far as converging, but it supports that too, and also OSPF. And so what I would like to do is, in the next set of videos, let me go ahead and do some demonstrations. Now, in the NRC course or the NRC certification, the objective is to describe or understand the concepts of what BFD is. And I think that we've just covered that to some degree, but I also think that reinforcing that a little bit is going to be huge, because when I was looking at some documentation regarding this, I thought, wow, that's for some of these, it's not quite as straightforward as I would have guessed it might be. So by demonstrating, let's go ahead and do demonstrations of BGP and static and EIGRP and OSPF. That'll give us a good sampling of how to implement it, also how to look at it, and also verify that it is working so we can test it as well. So I'll demo these. Now, one word of caution. If you want to do these in your own lab environment, virtual environments don't do well with BFD. So BFD is really good if you have physical environments with a lot of processing power and electronics on the interface cards that are doing a lot of the heavy lifting. If you're doing it all in a virtualized environment, the central CPU that's running the virtualization software is going to have to handle that. So I just want to give you a word of caution before you load this up with, sub-second BFD messages going back and forth in a virtual environment. It may cause you grief. But also, what I will do is, this is Cisco Modeling Labs, which I'm going to demonstrate this on, and also show you how we can tone it down a little bit for demonstration purposes, or so you can practice in a virtualized environment, so you can still practice with it without locking up your whole system, which I've done a few times. So I will see you in the very next video where we'll do an example of implementing and verifying BFD. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.